So now we're going to discuss a particular characterization of certain kinds of lines. That is to say, parallel and perpendicular lines. Now from geometry, we know that two lines, let's say L and K, are parallel if they never intersect, if they never touch. You know, your typical example is like this. You have like L is a line like this, okay? And you have a line K. Man, even when I want to draw something right, it doesn't come out. I swear, if Michelangelo had seen a line like this, I would have been berated for drawing poorly. Just kidding, of course. Okay, so then let's say this is line K. Let's say that's, okay, much better. So this is like the typical idea of what parallel lines are. They extend forever without ever meeting each other at any point. Now, on the other hand, we also have the other characterization. Two lines, L and K, are perpendicular if they intersect in a right angle. So, for example, I can have, like, let's say this is my L, and let's say this is my line K. Okay. And what the perpendicularity is that this is the case. Okay, that they intersect in a right angle. And of course, like depending on the situation, there might be other properties from geometry that we might need to use, such as, for example, there is only one parallel to a line through a point not on the line, for example. And of course many others. All right, but for right now, these are the kinds of situations we're talking about. L and K are parallel if they never touch. L and K are perpendicular if they intersect at a right and make a right angle at their intersection. So now we're going to talk about some of the algebraic characterizations of parallel and perpendicular lines. We use the notation L with two lines that are like this in K to indicate that L is parallel to K. And we use this kind of like footed T, upside down T, to indicate that L is perpendicular to K. Okay. And now the algebraic characterization that we're going to use to solve some problems in algebra are, if suppose that L has the slope m sub L and K has the slope m sub K, then L, the line L, is parallel to the line K, or we say L parallel K, if the slope of line L is equal to the slope of line K. And L is perpendicular to K, the line L is perpendicular to the line K, if the slope of line L is the negative reciprocal of the slope of K. And of course, if this property of the slope, if you have two lines with two slopes and they satisfy this property, then the lines are parallel. They will never touch. There will be no point that satisfies both line equations. If this property is satisfied, if you have two lines whose slopes satisfy this property, then those lines will be perpendicular and they'll intersect at one point, and they'll intersect forming a 90-degree angle. If neither of these conditions is satisfied, then the lines intersect, but they're not perpendicular. Thank you.